How exactly the data is stored in Hadoop, right? Yeah. Before I start, can one please confirm whether my voice is clear, whether the screen is visible or not? Yes. Yeah. Can anyone please confirm whether my voice is clear, whether the screen is visible or not? So in Hadoop, data is stored in the form of files. Each file is again subdivided into blocks. Default block size 64 MB. In latest version, it is 128 MB, right? f1.txt 200, for example, 200 MB, right? So it is divided into blocks, 64 MB blocks, 200 by 64, four blocks are distributed across the three, four slaves, right? Four systems are going to store this, right? S1, S2, S3, and S4, right? So design principles with respect to HDFS blocks. Every file will have dedicated number of blocks. Every file will have its own blocks. In a single block, no two files data are to be stored. All the blocks will have equal volume except the last block. Increasing or decreasing the block size. The file is divided into blocks, right? The file is divided into blocks, 64 MB blocks. So 64 or 128, but even we can set our own block size. Even we can set our own block size, right? So for configuring the block size, increasing or decreasing, right? Yes, go to Hadoop installed folder. Go to Hadoop installed folder, right? Within the conf, hdfs-site.xml, right? So within the Hadoop installed folder, go to that conf subfolder. Within that, we see a file called hdfs-site.xml file. Within this XML file, right, it will be an empty file. This will be an empty file, right? So we need to write the following configuration. Configuration and slash configuration, right? And property and slash property. XML tags means we can write our own tags. In this property, name dfs.block size. dfs.block size. What is the value you want? 50 you want, 100 you want, 10 you want, 20. What is the block size you want to provide, right? You can just provide 50 MB or 100 MB or 150 or 200. Yes. Yes. Which is advantageous? Keeping the block size smaller block size, or what is that advantageous having that bigger block size or smaller block size? By default, it is 64 or 128. But we can also configure our own block size. We can also configure our own block size, right? So if I keep that block size as a bigger block size or smaller block size, which is advantageous? Mm.
Smaller one.
Okay, just observe here. One second. Now, which is advantageous? Having bigger default block size or smaller one means? For example, for example, there is a file f1.txt file. As observe here, there is a file f1.txt. The file size is 900 MB. Your file size is 900 MB. So I'm keeping the default block size as 500 MB as a bigger one. 500 MB, I'm keeping the default block size. So the file will be divided into how many blocks? 900 by 500. Two blocks. One will have 500, other one will have 400. Means two blocks, B1 and B2. So this file is divided into two blocks. The first block will have 500 MB, second block will have 400 MB. So two blocks stored in two systems. It means assume you have got 40 node cluster. Your cluster has got 40 systems, 40 node cluster where you are using only two slaves. Means for example, I'll give you a labor example. For a constructional work, you have got 40 labors. You got 40 labors for building construction. In that, you are using only two slaves. Only two labors are working. Remaining 38 are not working. So means only two slaves or two systems are running parallel, right? We get lesser speed. But in such case, if you engage all the remaining slaves, then you can achieve more speed, right? So if you have kept the block size as at least 100, if you have kept nearly 9 systems might be running, right? If you have kept 100 MB as the block size, default block size, it should have been distributed across 9. But here only two systems are running. Two systems are running instead of if the default block size if it has 64, nearly 15 slaves should have been running parallelly. Nearly 15 slaves should have been running parallel. Should have achieved more speed, right? Yes. Understood, right? So you cannot have that default block size as a bigger one. If that's the reason, Hadoop is providing the default block size as 128 MB for the latest versions. Previously, it was 64, right? So we cannot have default blocks. What is the drawback? Only less number of slave systems will be involved, where you cannot get more speed. So here, if it was 64, nearly 15 systems should have been running parallel. Okay, now someone answered, right? The default block size, if we keep small, it is advantageous. So let us take one example on that. A file, just a very small file, assume 50 MB file. 50 MB file. Default block size is 5 MB. Default block size only 5 MB also. Assume here file size is 50 MB and my default block is 5 MB. But stored across 10 systems, right? Means 5 MB default block size means this file f1.txt data is stored across 10 systems, which 5 MB, 5 MB, 5 MB in 10 systems and processed parallelly. So already it's a very small file. It is already a very small file divided into smaller parts and computed and the output is collected. It is a time taking process, right? It is a time taking process. A small file divided into smaller parts, distributed across multiple systems, computed again, output should be collected, right? The time taking. So the block size should not be too big and too small. So if you are kept a very small block size, you need to distribute, you need to compute, and you need to retrieve it. So it's a time taking process, right? So the file size should not be too big or too small. So in the latest versions, the default block size is given as 128 MB. The default block size is given as 128 MB, right? Yes. So Hadoop is giving the default block size. Yes. As I was discussing three cases, right? Data storage and data processing. Observe this data storage and data processing, right? Case one, case one, clearly I have provided the notes for it. We have gone through the notes. Yes. If the number of blocks is equal to the number of slaves, means file will be divided into blocks, right? If the number of blocks is equal to the number of slaves, then I'm saying it's full parallelism and very high speed, right? Four blocks means B1, B2, B3, B4 into four slaves. I've got a file f1.txt with 240 MB. Default block size is 64 MB. Assume number of blocks, whatever the file size by default block size. 240 by 64. 240 by 64 means nearly you are going to get 4 blocks. 240 by 64, 4 blocks. B1, B2, B3, and B4. So these 4 blocks are stored across 4 systems like this. 4 blocks, B1, B2, B3, B4, they are stored across 4 systems. Means the slaves are storing the data, but master node, which has got name node, right? It is maintaining the metadata information. F1.txt into 4 blocks in 4 slaves. Which block stored in which slave, all the information will be available within the name node. It only maintains the metadata information, right? Here master node. Here master node stores metadata information. Master node maintains what? Metadata information. Metadata means data about data. Metadata means data about data. Yes. Okay. Now data processing, right? Job is to process the file f1.txt. Always the job, it is divided into tasks. Then only the parallel processing can happen. So number of tasks in Hadoop always depends on number of unique blocks. Number of unique blocks, how many? 4 blocks. So here you will see 4 tasks. 4 tasks means job of f1.txt into 4 tasks T1, T2, T3, T4. T1 is for executing B1 block. T2 task is for executing B2 block. T3 for executing B3 and T4 for executing B4 block. Who should execute this T1? S1. Who should execute this T2? S2. Who should execute this T3? S3. T4 by S4. So four tasks are executed by the 4 slaves parallelly. 4 tasks are executed by the 4 slaves parallelly, right? Here 4 tasks are executed by 4 slaves. Here no task is in the waiting state. So full parallelism, very high speed. All the 4 tasks executed by 4. But in the case 2, if you observe, if the number of blocks are more, number of slaves are less. 4 blocks, only 2 slaves. Less speed because your file 240 by 64, 4 blocks you get. But 4 blocks, for storing 4 blocks, only 2 systems, right? B1 storing 2 blocks, S1 storing 2 blocks, S2 storing 2 blocks. So S1 has, okay, data processing, job is divided into tasks. Number of tasks in Hadoop always depends on number of unique blocks. So four blocks here. So four tasks here. Four tasks, right? Job is divided into four tasks. Who should execute T1? S1. Who should execute T2? S2. T3 again S1. T4 again S2. Because only two systems are there for executing all the four tasks. S1 should execute two tasks. S2 should execute two tasks. But here in S1, T1 is executing. In S2, T2 is executing. But T3 and T4 will be in the waiting state, right? So some tasks will be in the waiting. So here we will get lesser speed. More blocks and only one slave. If you got more blocks, only one slave. Then no parallelism at all. Four blocks are there, only one slave. In this case, all this B1, B2, B3, B4, they are stored in a single system S1. So B1 stored by S1, B2 also by S1, B3 also by S1, B4 also by S1. All the four blocks are stored by S1 only. And if you go for data processing, right? You go for data processing, number of tasks always depends on number of unique blocks. I'm using the word unique. I'll say in the next coming examples why I'm using the word unique here. Here, how many blocks? Four blocks. Four blocks means four tasks. T1 for executing B1, T2 for executing B2, T3 for B3, T4 for B4. Who should execute this T1 task? S1, T2, S1, T3, S1, T4 also S1. Four tasks are executed by only one slave. The four tasks are executed by only one slave, sequentially one after the another. They are executed sequentially one after the another. So no speed, no parallelism at all, very low speed. Okay. In case one, right? In the three cases what we have discussed, right? In case one, case two, and case three. In case one, job is divided into four tasks. Four tasks executed by four slaves, S1, S2, S3. Assume each task takes 1 hour. Total time taken for all that four tasks, only 1 hour. In case two, four tasks executed by two slaves, two systems. Assume each task takes 1 hour. Time taken for all the four tasks, 2 hours. In the case three, time taken to execute all the four tasks, 4 hours it takes because only one system is one, right? Observe this case one, right? Once you go back to case one, yes. A file with 240 MB, four blocks you got, four slaves, S1, S2, S3, S4. Four blocks are stored in four systems and four tasks, right? T1, T2, T3, T4. When four tasks are executed by the four systems, S1, S2, S3, S4, suddenly S2 is down. Suddenly S2 is down. Means 10 lakh records are lost. When the system 2 is down, 10 lakh records are lost. Suddenly, if S2 is down, then we observe two things. Data loss. Data loss. That is B2 block is lost. B2 block is lost. Task is failed. The T2 task, the T2 task which is executed by S2, right? That is also failed. So Java also failed. How Hadoop is able to overcome this kind of situation means replication and fault tolerance mechanism. What is that? Replication and fault tolerance. What do you mean by replication and fault tolerance? To overcome this, replication and fault tolerance in Hadoop. Replication means duplication. Duplication of what? The file or the blocks. Default number of replications in Hadoop. Default number of replications or replicas in Hadoop is 3. We can also configure increase or decrease the replications. We can also configure increase or decrease the replications. Okay, later I'll show you how to increase or decrease the replication. But now understand what do you mean by replication and fault tolerance, right? Just remember default number of replications in Hadoop are 3. Once try to confirm me, right, whether my voice is clear to all.
Yes, yes, it's clear.
Sir, fault tolerance means
Yeah. You understand this example, you will understand what do you mean by fault tolerance. Replication and fault tolerance. Observe here. I want the sessions to be interactive. Everyone try to answer, right? So just I'm going to make you understand about what do you mean by replication, fault tolerance. Hmm. F1.txt. The size of this file. Assume it's 192 MB. Assume the first file size is 192 MB or GB or TB, whatever it is. That file is divided into blocks. Assume you have taken the default block size as 64 MB. Into how many blocks it is divided? Number of blocks. So your file size by default block size 64. You will get what? 64, 64, 64, 3 blocks you will get. 3 blocks means B1, B2 and B3. Observe here. B1, B2 and B3. Here replication. What is the default number of replications in Hadoop? Yes, try to answer. What is the default number of replications? How many replications we can have? How many duplications we can have in Hadoop? By default, 3, right? So B1 by 3 times, B2 by 3 times, B3 by 3 times means duplicated by 3 times. Totally how many blocks you get? How many blocks we get, right? 9 blocks. How these 9 blocks are going to be stored across the cluster? How these 9 blocks are going to be stored across the cluster, right? This is your master node, this is your master node, and these are your slaves. Assume you have got 3 slaves. In Hadoop, your file will be divided into smaller parts. Default, each part will be of 64 MB here. 192 by 64 into 3 parts here. 3 blocks we say. But B1, the B1 block I am duplicating by 3 times, B2 by 3 times, B3 by 3 times. Total 9 blocks. Thus 9 blocks I got S1, S2 and S3. 3 slaves, 3 systems, right? Here 9 blocks totally. B1, B2, B3. And here B3, B1, B2, B2, B3, B1. The 9 blocks stored across the 3 systems, right? 9 blocks stored across the 3 systems, right? Okay, here the name node, master node consisting of this name node. Name node always stores the metadata information. Name node always stores the metadata. This slaves stores the actual data. Metadata means data about data. F1.txt. F1.txt file into how many blocks? B1, B2, B3 into 3 blocks. B1 stored in system 1, in system 2, and system 3. B2 also stored in system 1, in system 2, and system 3. P3 also stored in system 1, system 2, and system 3. Observe here, each block stored across these 3 systems, 9 blocks total. So yes, here data processing, if you talk about the data processing, right? Yes. To process the file, job is to process this f1.txt file. It always divides into tasks, number of tasks. Number of tasks always depends on number of unique blocks. Number of unique blocks. Number of tasks equal to number of unique blocks. How many unique blocks? Number of tasks equal to number of unique blocks. How many unique blocks here? 9 or 3? 9 or 3? 3, right? Yes.
3 unique blocks.
3 here, not 9. 9 are duplicated blocks. That's why the word unique I have used, right? Not duplicated, right? Unique blocks. 3 blocks means 3 tasks. T1, T2, and T3. Job is to process f1.txt, yes. Into how many tasks? 3 tasks, right? 3 tasks here. T1, T2, and T3. T1 for executing B1. For executing B1. T2 for executing B2. T3 for executing B3. Now try to answer who should execute the T1 task here. The previous examples, what we have discussed as B1 is present in S1, S1 only should execute. But B1 now it is present in S1, S2, S3. All these 3 slaves are eligible, right? S1 can execute this T1, S2 can execute this T1, X3 can execute T1. But which one is selected among these 3? So what is the criteria followed in assigning the task to the particular slave? Assume master node has selected S1 only for executing the T1. Later I discuss what is the criteria followed here in assigning the task to a particular slave. So this T2 task also can be executed by S1, S2, and S3 because the B2 is present here in S1, in S2, and in S3. So previously, in the previous examples, B2 is present in S2 only, so S2 only should execute that. Since B2 block is present in S2, S2 only should execute, right? But here, S1, S2, S3, assume master node has selected S2 only for executing the T2 task. Here, S1, S2, S3. T3 also can be executed by S1, S2, and S3. Assume master node has selected S3 only for executing the T3 task. Yes. So T1 by S1, T2 by S2, T3 by S3. Now assume T1 is assigned to S1, T2 by S2, T3 to S. 3 tasks are assigned to the 3 systems, 3 slaves. Now, when three tasks are executed by the three systems S1, S2, S3, suddenly a particular system is down. S2 is down. T2 task will fail and this data. But here, observe these two things. Previously, when the particular system is down, the data is lost. B2 block was lost. Now, can you say, is B2 block is lost here? Previously, S2 was storing only B2, S1 was storing B1, S2 was storing B2, S3 was storing. If the system S2 is down, do you see any data loss? If the system S2 is down, do you see any data loss? Still that B1, B2, B3, the blocks, they're available in S1 and S3. The three blocks are available in S1 and S3. Even if S1 also down, right, still S3 is available with all the data. So there is no data loss here. And T2 task, which was assigned to S2, now the master node can assign to any of the other. The T2 task can be assigned to either S1 or S3. Anyone has to perform two tasks. So there is no data loss. So there is no data loss. And there is no task failure, right? So even though if any particular system is down, still as there is a replication, right? Duplication, still the data available in other systems. And the T2 task can be done by S1 or S3, right? So S1 or S3 is going to execute the T2 task. But here I got some couple of queries. So here, T2 task you are going to assign to S1. Which one? S1 or S3? Which one? What is the criteria followed in assigning the T2 task? That is one. And here also, when T1 can be executed by S1, S2, and S3, why you are given the T2 task to S1 only? Why it was assigned to S1? What is the criteria followed in assigning a task to a particular slave? So here, again, observe this. S1 is executing T1 task. S2 executing T2 task. S3 executing T3 task. Suddenly this S2 is down. Then the T2 task should be assigned to S1 or S3. What is the criteria for to whom it has to be assigned? So here we have got a 4 steps criteria. We have got a 4 steps criteria, right? In assigning the task to in assigning a particular task to a slave, 4 steps criteria. First step. Four steps criteria. It's a 4 steps criteria. First one, master node selects. Master node selects. Master node selects the slave. Master node selects the slave which is highly configured. Which is highly configured. So first one, what is the first step? 4 steps criteria followed in assigning the task to a slave. The master node selects the slave which is highly configured among S1 or S3. Highly configured means hardware configuration. Assume both are equally configured. Assume both are equally configured. Then second criteria, if both are equally configured, right? Then master node selects the slave. Master node selects the slave. Master node selects the slave, yes, which is more ideal. Which is more ideal. Master node selects the slave, which is more ideal. More ideal means more free. For example, S1 is executing 3 tasks, S3 is executing only 1 task. So assign to S3 as it is just performing less number of tasks. So don't burden S1 by assigning one more task to it. So assume both are free. Assume if both are free. If both are free, then to whom to assign? So here, master node selects the slave, which is nearest to it, Nearest to it means master can be in one country, slaves can be in different countries. Master can be in one state, slaves can be in different states. Master in one city and slaves in different cities. Otherwise, all within the same city or all within the same lands. Master and slaves, right? Then if both are equally near, if
I have
bo-
a question.
if both are equally near, yes.
This slave configuration, can we install all these slaves on the cloud so that it can automatically adjust their configuration, right? Auto
Yes,
scaling.
yes. So
Okay.
yeah, that too. Okay, when I'm not talking about the configurations, right? So master and slave, so okay, everything you can do in cloud side. But
Mm.
here, if any system, for example, if anything is down, if anything is suddenly because of some reasons, if anything is down, then the task has to be assigned to whom?
Okay.
The first thing is all are equally okay. It's just saying all are equally configured. Then you can
Mhm.
go with the second option, right?
Right, right.
Which are more free.
Yes,
Master
yes.
it selects the slave which is more free. For example, S1 is performing four tasks it is executing, one after another. Some other 3 tasks are in the waiting state for it. S3, only one task it is performing. So S3 is more free, right, than S1. So you can assign to S3. You cannot burden S1 by assigning one more task to it.
Right.
Or otherwise S3 it is not performing any task. You can assign to S3. But assume that both are not performing 0 tasks. Both are free. If both are free, right?
Mhm.
Okay.
So do you have a cloud service, Hadoop cloud service on the Azure or AWS?
Yes, we have got AWS.
Okay. Okay.
Okay.
Thank you.
Master node selects the slave which is nearest to it, right? Which is nearest to both. If both are equally near, then finally master node selects the slave which has good health status, right? Which has good health status means even though they have got same configuration, now and then because of some hardware or software issues, it is going down, right? So in such case, which has got good health status to that you can assign. If both have got good health status, then master node selects any one slave randomly. Master node selects any one slave. In the extreme case, master node selects any one slave randomly. So this is the criteria followed in assigning a task to a particular slave internally. Internally, what is that criteria means? This is the criteria followed. Now try to say me Replication, you understood what do you mean by replication? Replications means duplications. Okay. Now, what do you mean by fault tolerance? Replication, okay. Duplication. What do you mean by fault tolerance means? When multiple tasks are executed by multiple slaves, if any one system goes down, then the task of it is going to be assigned to any of the available slave. Then this process is called as fault tolerance mechanism. Assigning a task to other slave during a failure of a particular slave. The process is called as fault tolerance mechanism. Just observe this process. Yes. The same thing I've explained clearly here, replication and fault tolerance. So B1 duplicated by 3 times, B2, B3, 9 blocks. 9 blocks stored across in 3 in system 1, 3 in system 2, 3 in system 3. 9 blocks. Data processing, right? Number of unique blocks means 3 only. So T1 can be executed by S1, S2, S3, T2 by S1, S2, S3, T2. But okay. Okay. What is the criteria followed in assigning a task to the slave? The 4 steps criteria what I discussed now, right? Okay. What is fault tolerance? If multiple tasks T1 are executed by multiple slaves, suddenly if any one slave goes down, then the task will be assigned to the available slaves. This process is called as fault tolerance. This process is called fault tolerance. We can configure, I said we can configure, increase or decrease the replications, right? By default, it is three times, right? But if you want to increase more, make it as 4 or 5. Go to the Hadoop installed folder. Go to the Hadoop installed folder, right? Conf folder, hdfs-site.xml. How we can configure a block size and replication. Replication means we can keep our own like 4 times, 5 times, 6 times. If data is more sensitive, go with more replications. If it is insensitive data like Facebook or any social media data, we can keep 1 or 2 kind of replications. So here, whenever you go to this hdfs-site.xml, by default, it will be an empty file. There won't be any data in that. So you can just configure in this way. First property and second property. 2 property tags. In that first property name, dfs.block size, distributed file system dot block size is the property name. What is the value you are setting? As 50 MB or 100 MB or 200 or 10 MB, whatever, right? You can set your own block size. What is the second property? dfs.replication. How many replications? By default 3, right? But you can increase to 4 or 5 or decrease to 2. Increase or decrease. And what are the principles you need to follow? Design principles with respect to replication. With respect to replication, what are the principles means? Replications or duplications is applicable only for data, but not for metadata, right? Actual data only, data blocks. Replication is applicable only within the slave nodes, but not within the master node, right? Replication is applicable only within the slave nodes, but not within the master node. There is no replications in the master node. Yes. All the same replicas cannot be stored within the same slave. All the same replicas cannot be stored within the same slave. In a single slave. What is this third point? Have you understood this third one? All the same replicas cannot be stored within the single slave. For example, okay, you are maintaining replications, duplications, but this is incorrect. Which one? If you have got this is the master, these are the slaves. These are the slaves, right? S1, S2, and S3. S1, S2, and S3. Okay, replications are maintained. 3 replications means totally 9 you will get. 3 into 3, 9. Previously, we have stored B1, B2, B3 in S1, B1, B2, B3 in S2, B1, B2, B3 in S3. That is how you are stored. Now, observe. If you are doing in this way, B1, 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 B2, 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 B3, B3, B3. If suddenly S2 is down, total B2 blocks are lost, B2 data. There is no B2 data available in other systems. B2 data is not available in the systems, right? So there is a loss in the B2 data, right? There is a loss in B2 data. So all the same replicas cannot be within the, all the same replicas cannot be within the same single slave. They should be distributed across it, right? So just I said this kind in S1, all B1s in S1, all B2s in S2, all this is not valid. Okay, fine. So next, discussing about this Hadoop architecture, right? Hadoop architecture. And before I go with this,
Good question.
Hmm.
If
Go ahead.
name node is down, only one system, right? Name node.
Hmm.
Suppose if it is down,
Hmm.
then the entire system will go down, right?
If name node is down, then entire cluster will be down.
So there is no replica for name node.
No, 1 second. Yeah, good query. Just observe here. Master, these are the slaves. Master and slaves. S1, S2, S3. So if one slave is down, we have got another slave to process. If that slave also down, this S3 can process that. But if this name node or this is down, if name node is down, right? When name node is down, then immediately, just like in the absence of the principal, we have got vice principal, right? Here also in the absence of the name node, immediately we have got secondary name node. We have got secondary name node. The secondary name node will be running immediately. During the absence of the name node, we have what secondary name node. Until the name node is up, secondary name node will be running, right? So this I'll be discussing in the Hadoop architecture, right? Name node, secondary name node, and data nodes. Yes. Okay. Hadoop architecture. Hadoop architecture, right? Storage architectural components. Processing architectural components. Yes, we have got storage architectural components and processing architectural components. See, Hadoop is meant for storage. Hadoop is meant for storage and processing. Hadoop is meant for storage and processing. For storage, right? For storage, HDFS. Hadoop distributed file system. For processing, MapReduce. For processing, we have what MapReduce. Yes. Again here in HDFS for storage, right? We have what three things. Name node, data node, secondary name node. Name node, data node, and secondary name node. These are storage architectural components, right? Yes. Map here for processing, we have got job tracker, task tracker. Processing architectural components. Processing architectural components, right? Yes. Okay. First, we discuss about the storage architectural name node, data node, and secondary name node. Next comes to this job tracker, task tracker, processing architectural, right? First, talking about this name node. I got a file f1.txt. 192 MB. Number of blocks 192 by 64. Default block size 3 blocks. B1, B2, and B3. Now, based on this, you try to say me the responsibilities of name node now. 3 blocks. This is master. These are the slaves. S1, S2, S3. B1 here, B2 here, B3 here. B1 here, B2 here, B3 here. This is the master name node, right? Within the master node, we have what a name node. Name node stores the metadata, data about data. When B1 is stored, B1 block is stored in S1, it is going to occupy some memory location, right? XX. For this B2, it is going to occupy the memory location. So these are physical memory locations, right? Physical memory locations. Means B1 is stored in so and so memory address, B2 is stored in so and so memory address YY. So if I want to retrieve F1 dot txt means B1 plus B2 plus B3. B1 in so and so, B2 in so and so, and B3. It has to just B1 means it has to go and access this memory location B2 and B3. Understand means here what is the name node responsibility? If you got f1.txt into how many blocks it is divided, B1, B2, B3. They are stored in which systems? In S1, S2, and S3. And what are the memory location addresses for this XX, YY? That's it. Means what it has to maintain. The blocks, the file has got how many blocks stored in which slaves and memory location addresses. This entire thing maintained within this name node, right? So now based on this, try to say name node responsibilities. Okay. Check this, right? The responsibilities of the name node one by one from the above diagram. Name node responsibilities to store the physical memory locations of the blocks of a file. To store the physical memory locations of the blocks of a file. And also combining which combine the physical memory locations of the blocks so that the file can be formulated. Name node stores the metadata information. Name node stores the metadata information. That is data about data. Okay. Next is data node responsibilities. Only one responsibility of the data node to store the HDFS blocks, to store the blocks of a file. To process, again, we have what processing components separately. Data node responsibility is only storing the data blocks. The number of data nodes required depends upon the volume of incoming data. Secondary name node, right? Secondary name node. If name node is down, then the entire cluster will be down. So if name node is down, then immediately we have what secondary name node. Secondary name node responsibilities also same as name node only. The three responsibilities what we have seen in name node, that's the same responsibilities. What? Secondary name node responsibilities are also same. Storing metadata information, combining the memory location so that the file can be retrieved. Physical app to store the physical memory locations. But secondary name node is not 100% a backup node for name node. Secondary name node is not 100% a backup node for name node. That is, in the absence of, for example, a labor example, in the absence of the principal, vice principal cannot make the decision making immediately. He has to wait for the principal to come. Same way, in the secondary name node is not 100% a backup node for name node. But name node can read, write, and update, whereas secondary name node can only read. Secondary name node can only read. Okay. I'll give a labor example to understand the secondary name node. You got a district collector is our district collector. Is going on a leave for 30 days. For example, from June 1st to June 30th. So during his presence, he used to run the operations, he is maintaining a file. So he can he can read from it. He can write into it. But in the absence of the district collector, right? Yeah, got it. In the absence of him, deputy collector. Deputy collector, he can only read from it. He cannot write into it. So during the absence of the collector, deputy collector maintains his own. So when the collector is back after 30 days on July 1st, he will read the data from this and he will update into it. He updates into it. Means this whatever into this file, he is able to write, he is able to read, he is able to update. But deputy collector, he can only read, he cannot write or update into it. So this is what secondary name node. This is what a name node. Name node can read, write, and update, but secondary name node can only read. So here, I'll just provide one more example, right? First, understand this, what is happening within the name node. What is happening within the name node? This is your name node. Later we come back to the secondary name. Any system, any node in your cluster will have both LFS, local file system, that is Linux, HDFS, Hadoop distributed file system. If a file f1.txt divided into blocks, this blocks also stored metadata, right? This metadata also stored in the form of blocks. Metadata also stored in the form of blocks. Metadata also stored in the form of blocks. See, name node will store only the metadata, it won't store the actual data. So metadata, how it is stored in the form of blocks. Metadata also stored in the temp folder. From here, from here in a timely manner, stored in timely manner means daily, weekly, monthly, stored in two special files. Understand this metadata management. Metadata is stored in the form of blocks within the H, and from there it is also stored in the temp folder of LFS. From there temp folder, it will in a timely manner copied into two special files. FS image edits, and it is copied into two special files, FS image and edits. Copied into two special files, FS image and edits, right? Yes. So here we have got FS image and edits. In a timely manner, they are copied. This is what happening within the name node. Now, see this morning 7 a.m. to 8 a.m. name node running. 8 to 9 a.m. name node running. At 9 a.m. name node down. 9 a.m. to 10 a.m. secondary name node running. At 10 a.m. name node is up. 10 to 11 again. Name node running. Name node was down for 1 hour. It's a big loss. Name node is down for 1 hour. During this 1 hour, secondary name node was running. So now check this differentiation between this name node and secondary name node. This is the name node. This is the secondary name node. Both will have, any node is going to have local file system, Hadoop distributed file system, local file system, Hadoop distributed file system. See, f1.txt. It's metadata stored in the form of blocks. Metadata stored in form of blocks. Metadata stored in blocks. It is also stored in the temp folder. Metadata stored in temp folder. In a timely basis, think hourly. We have got FS image and edits here. Two special files from 7 to 8, okay. 8 to 9, okay. At 9 o'clock, it is down. When it is down, right? Secondary name node, it can read that metadata from this FS image and edits. It can read the data from this FS image and edits. And during the absence of this name node, from 9 to 10, it maintains the data, metadata within this temp folder. And name node, when it is up, can read the temp folder and updates, reads and updates in this FS image and edits. Again, from 10 to 11, it updates. During the presence and during its absence, right? Everything will be updated in this FS image in edits. So that's why I was saying, what is that? It's not 100% backup node. Name node can read, write, and update, but secondary name node can only read. Means name node can read, write, or update into FS image and edits files. Secondary name node can only read. Yes. And if I talk about this processing architecture, processing architecture, process architectural components. We have got job tracker. We have got a task tracker. See, job tracker resides within the master node. Task tracker within the slave node. So if you got this is the master, these are the slaves. S1, S2, S3. This is the master node. Within the master node, you will have name node and job tracker you will have. Within the slave node, you will be having data node 1, data node 2, data node 3. And task trackers. Task tracker 1, task tracker 2, task tracker 3. Who assigns the task? Job tracker to the task trackers. T1 task is assigned to task tracker 1, T2 task to task tracker 2, T3 task. Job tracker assigns the task tracker executes the tasks. So within the master node, we see two things, name node and job tracker. Name node for storage, job tracker for processing. Who is the master for storage? Name node. Who is the master for processing? Job tracker. And see this job tracker responsibilities and task tracker responsibilities. Job tracker resides within the master node and task tracker within the slave node. So name node for storage, job tracker for processing. The number of task trackers equal to number of slaves, but only one job tracker. Job tracker responsibilities, assigning the task, balancing the load, fault tolerance mechanism. If any one system is down, the task tracker is down, then the task has to be assigned to another task tracker. Health monitoring. Task tracker responsibilities to execute the tasks given by job tracker. And once task is completed, provides acknowledgement to job tracker. Task tracker send heartbeat signals to job tracker for every 2 seconds. How job tracker comes to know that task tracker is down means based on heartbeat signals. Now, try to answer. I've got some queries here. Now try to answer the query. Yes. Who is the master for storage? Who is the master for storage? Yes, try to answer, everyone. Unmute yourself and try to give your responses. Who is the master for storage? For storage,
Name node.
name node. Who is the master for processing? For processing everything taking
Job tracker.
job tracker. Who divides a file into blocks and distributes across the multiple slaves? Who divides a file into blocks?
Name node.
Name node. Name node divides a file into blocks and stores across these multiple slaves. For example, if any job is there, job has to be divided into task, right? And here, who divides a job into tasks? Who divides a job into tasks and assigns the task to multiple task trackers? Who divides a job into tasks and assign the task to multiple task trackers?
Job tracker.
Job tracker. Who is responsible for fault tolerance? Who is responsible in fault tolerance?
Name node.
Name node fault tolerance means processing related. Processing related name node won't take care. Only storage related, only name node. Who is responsible for fault tolerance means if any task is failed, the task will be assigned to another task tracker. If any task is failed, the task will be assigned to another task tracker by whom? Job tracker. Who stores the actual data? Slave node, data node, right? Who stores the actual data? B1 block, B2 block, B3 block. Data blocks. Who executes the tasks? Who executes the tasks? Job tracker assigns the task. Who executes the tasks? Job tracker assigns the tasks. And who are going to execute the tasks? Task tracker. Who executes the task? Task tracker. Who stores the metadata information? Who stores the metadata information? Who stores the metadata information?
Name node.
Name node. Who takes care in absence of name node?
Secondary name node.
Yeah, secondary name node. Understood, right? So understand clearly here. This is the master node. These are the slave nodes. Slave nodes S1, S2, S3. S1, S2, and S3. So within the master node, we see two services. One name node as one service, job tracker. Name node will be always taking care about the storage point. Job tracker always takes care of processing.
Sir,
So-
in the fifth question, if it's asking fault tolerance, it should be two fault tolerances, right? One is file system tolerance and another is job level. So if job level, it's job tracker, but again, the file system HDFS level, it should be the name node, right?
Who is responsible for fault tolerance means what? What do you mean by fault tolerance?
If one of the node goes down, so that the data,
No,
bringing up or
No, name node doesn't do anything in that. Name node doesn't do anything in that. Name node, okay, the data, whatever is there in that particular slave is lost. Name node cannot bring the data back. So only thing is, okay, in the other slaves, the data is available. In the other slaves, there is a backup. But name node is nothing doing, it's not doing anything in that. Fault tolerance is based for what? Jobs and tasks only. If 3 tasks are executed by 3 systems, right? If any one is down, then the task is to be, means when 3 task track, see one thing, when 3 task trackers are executing 3 tasks, any one is down, then that particular task will be assigned to another task trackers. So in the previously I said in a generalized way, right? But now, previously I didn't discuss anything about this job tracker and task tracker, right? Now, understand here, 1 second. Clearly, within the master node, you got name node and job tracker. And within the slaves, you got a data node and task tracker. Data node 2, task tracker 2, data node 3, task tracker 3. See, anything related to storage will be taken care by name node and data nodes for storage related. Anything related to processing, job tracker and task trackers will take care. Who assigns the jobs? Who assigns the task? Job tracker. Who executes the task? Task trackers. Previously, in a generalized way, slaves executes the task, but within the slaves, we got task trackers. Those task trackers are going to execute the tasks. Slaves within the slave, right? They are just going to store data, but task trackers are going to execute the tasks. If see, if 3 tasks are executed by 3 task trackers, suddenly if this is down, then the T2 task will be assigned. T2 task will be assigned to another task tracker. By whom? Job tracker. Name node doesn't do anything in this case. Whatever data is there, the data will be lost here in this. Means data is, even though it is lost, still the data will be available in other slaves, right? Other slaves, there is a replication, duplication is available, right? So these are the services. Within the master node, we have got 2 services, name node and job tracker. Within the slaves, we have got data node and task trackers. Understood that, everyone? Yes.
yeah, okay.
So one thing, is I'll be providing the software, right? First thing is software. Nearly of, it will be of 5 GB file. It is a zip file. If we extract it, it will come up to 8 GB. It will come. It will be forwarded to your Google Drive. Second thing is videos. You will be getting to your Google Drive. Videos from here onwards, daily, every session video you will be getting to your Google Drive. Every week, the videos will be added to your Google Drive. Third thing, notes. Notes also will be forwarded to your mail, to your Gmail. And a WhatsApp group is going to be created, right? WhatsApp group. Once, okay, you need to get enrolled. Once you get enrolled, right? So everyone try to get enrolled. Yes, still if anybody not enrolled, right? Try to get enrolled by paying that fees. So I said, if you got enrolled, the software will be forwarded. The videos you'll be getting to Google Drive, the notes you'll be getting, and the WhatsApp group will be created and you'll be added to the WhatsApp group, right? Yes. And the thing is, I already said, right? It's Hadoop plus PySpark Linux. You got these three things, right? Yes. Hadoop, PySpark, and Linux. So, and this 12,000 is the fees for this, but still there is one more package, right? With Python package, with Python, right? With Hadoop, PySpark, Linux, and Python, the package is 15,000 with Python. So if you want this Python, you can attend any of my Python batches. Any of my Python batches you can attend, right? From Monday to Friday. It will be like nearly 60 hours of Python classes, Monday to Friday. So tomorrow there is a 2 Python batches getting started, right? At 8 a.m. in the morning and 7 p.m. in the evening, right? I said for the first week it will be at 8 a.m. Okay. Okay, 8 a.m. and 7 p.m., right? 8 a.m. and 7 p.m. For the first 1 week or 10 days, okay, 8 a.m. and 7 p.m. you can attend the sessions, right, everyone? If you choose Python. And Hadoop and PySpark will be discussed in the weekends, right? Saturdays and Sundays, right? Yeah. So get enrolled and get for getting all these things, right? And see this, yesterday someone was asking about the Python. This the big data Hadoop, right? MapReduce, Scoop, Yarn, NoSQL, HBase, Highwich for Hadoop, or PySpark introduction, RTD computations, persistence, aggregations, various actions, transformations, PySpark SQL, right? PySpark SQL functions, built-in functions, external sources, deployment modes, PySpark applications, right? And for Python also in brief, in depth, it will be discussed, right? Python basics, operations, operators, IDs, flow controls, looping statements, strings, collections, lists, tuples, sets, dictionaries, functions, modules, packages, errors and exceptions, file and object-oriented programming concepts, regular expressions, database connectivity, where it went. Dictionaries, functions, modules, file handling, object-oriented programming concepts, regular expressions, database connectivity, Python, datetime, OS module. OS module, advanced concepts, iterator generators, closures, GUI, Excel module, data analytics, introduction to data science, pandas, NumPy, and matplotlib. These 30 topics in Python will be discussed, right? So just to get enrolled, yes. You can see in the chart if anyone not enrolled. Yes. Can you see this? Yes. So you can see in the chart, right? The payment process details, if anyone not enrolled, the contact details also it's provided. See, anyone who have already got enrolled about the videos, you'll be check your Google Drive, shared with me option. If you already got enrolled, Google Drive, check your Google Drive shared with me option, right? You'll be getting the videos, right? Okay. And you can see the contact details. If you're not getting the videos, you can contact that online team. You got 3 contact details are provided in the chart panel, right? Payment. Yeah, someone was asking a query, right?
Where is the chart, sir? Actually,
The Zoom chart.
I actually enrolled, but I didn't get any videos or notes or anything like that. Actually, only for PySpark I got videos. Should we again ask for Hadoop videos and all that stuff?
No. 1 second. 1 second. By tomorrow morning, you'll be getting these videos, right? Today, class is completed, right? So by tomorrow morning, by 9 o'clock, you can get that all that in the drives. Already in the mails you are getting, right? Yes,
No,
right.
sir. I'm not getting the notes also.
In the chart you can see, right? In the chart you can see demo videos is given, right? Demo videos link is given, right? Yesterday's video Demo videos is given in the, can you see in the chart, demo videos? Yesterday video you can see in that. Today's video also they will be forwarding to your mail. But by tomorrow morning, if the people who have got enrolled, you can see in your Google Drive. One more folder you will see. But now can you see in the chart, demo videos is given. Yesterday video you can see in that. Today's video you will be getting to mail by today evening. And if you have enrolled by tomorrow morning, you will be getting a Google Drive link, right? Yes, fine. Okay. So next,
Linux also covers in the weekend or
Yeah, yeah.
weekdays?
No, in the weekends only. Next week, I'll be discussing with the Linux, right? Before I go with the practical part. Yes.
Okay, sir.
So next week, after next week, I'm going to start with the practicals. Before I go with the practicals, Linux is going to be discussed. And software I'll be providing to your Google Drives. And I'll be just demonstrating about the software in the next Saturday, right? Next Saturday about the software, demonstrating about it, and Linux commands I'll be discussing for understanding the HDFS commands, right? Yes. So I want the sessions to be more interactive, right? Whether your answers are correct or wrong, keep responding, right, everyone? Yes. And try
Could
to
you
be
please share
present.
the notes, sir?
Yesterday's notes I forwarded right at the end of the session yesterday. Now I will be forwarding today's notes also, right? In the chart.
Okay.
One second.
Sir,
Sir, we will be
PySpark at what times? 4:30 or 4, sir?
420.
4. Okay, sir. I did not receive any link, sir. I have enrolled.
Okay, just okay. One second. So
Okay, sir.
PySpark, right? Okay. One second. Let me make it clear about the PySpark, right? See here, first Hadoop is will be discussed right for the next 4 weeks. Hadoop next 4 to 5 weeks, right? Hadoop will be is going to be discussed. But later for your batch, first Hadoop will be discussed. Right? Totally it's 12 weekends, right? For Hadoop and PySpark. 12 weeks for this Hadoop and PySpark. For the next this first 6 weeks, Hadoop will be discussed, right? Nearly 5 weeks. For nearly next 5 weeks, right? Hadoop is going to be discussed. After that, for your batch, PySpark will be starting, right? But there was a PySpark batch started for the previous means nearly like 1 month or 1.5 months back. There was a Hadoop batch. There's another big data batch was started. For that batch, now currently at 4:15, right? There is a PySpark batch started for them. But as some of your batch students, right, who wants to attend both Hadoop and PySpark parallelly. But this PySpark is not for your batch, but the previous Hadoop, they have completed Hadoop. The people who have completed Hadoop, they are going with for PySpark now, right? But if anyone from your batch, if you want to go parallelly Hadoop and PySpark, for them I said, right, there is a batch. So just if you want to go parallelly Hadoop, PySpark and Python parallelly, right? Already the people who have already got the link, okay. If anyone who didn't get the link for PySpark means if you want to, means once again I'm saying 3 weeks, this is the 3rd week. If you have already got some basics, you can attend. Otherwise, I won't recommend go separately or go separately, right? After that, okay. But if you think that I'll complete the videos by next week, all that videos, PySpark videos, I'll understand. You can understand if you just go through, you will understand everything. You want to attend PySpark also parallelly, right? People who wants to attend PySpark also parallelly can just, if you have got enrolled, yes, you can ping me on this number, right? To get the link for today's class. Yes. So
sorry, sir.
I won't give that one second. You need to go through that previous 2 weeks videos actually to understand today's session. But today, if your understanding might be, if you're attending for the first time today, the PySpark, 50%, right? Understanding will be. So before the next Saturday, right? Try to go through all the videos, and if you attend, you can understand full better in the next week. That's what I'm, otherwise, after completion of Hadoop, if you want to attend PySpark, separately you can attend PySpark, right? That is your wish, yes?
Sir, 5 weekends means how many classes, sir, for Hadoop?
5 weeks to 6. Okay. Like 20, 22 hours I'll be spending. 5 weeks means in a week, nearly 4 hours, right? 5 weeks means 20 to 22 hours you'll get.
Okay, sir. Okay. Okay,
But
sir.
I said already, I said for PySpark, our concentration will be more on the PySpark. Okay, fine.
Okay, sir. Okay.
So I'll stop. Okay, 1 second. This is I've provided my number, right? If anybody who have got enrolled, if you want to attend PySpark parallelly, you can just send.
Sir, could you please
Sir,
share the today's
hello,
notes?
sir.
Yeah, today's notes. 1 second.
Sir, for Python class, should we contact for the link or I enrolled for all the 4?
So
Python class, the
again,
link.
for that link, okay, if you have got enrolled, you can ping me, right?
Oh, I also pinged you on WhatsApp to add me into groups, sir, actually, in PySpark and Hadoop.
So added into PySpark, no?
No, sir, no group actually.
Once again, you can ping me, right? If you want to
Yeah.
attend PySpark, you can attend. You can ping me
No,
now.
sir, I have PySpark link actually. I'm attending PySpark parallelly.
You want to add into the group, right? You can just
Yeah.
give a message now, immediately.
Okay. Okay.
Still anybody who are attending PySpark, right? If they want to get added into the PySpark group, you can ping me, right? In that number if you have got enrolled. 1 second.
Can I share it, my number here or
In the WhatsApp,
PySpark class?
in
Yes, sir.
WhatsApp,
Class.
in WhatsApp group, right? In WhatsApp,
Yes, sir.
give me a text message in the WhatsApp. Not here. So
Can you
here,
please share the numbers?
can you see 9912621686?
Okay. Okay.
So notes
I
is
will share it.
notes is forwarded. And one more thing I'm saying about the PySpark, right? It not in a, if you have got some basic knowledge of this Hadoop and this, you can go with. Otherwise, after 1 month, there'll be one more PySpark class, right? That you can attend. But if you got in urgency, if you want to complete it faster, you can go parallelly. Hadoop to PySpark, and otherwise go with Hadoop and Python parallelly. Later PySpark we can. Otherwise, we can go with all the 3 parallel. Fine.
Sir, how many weeks of PySpark, sir?
PySpark will be for nearly 7 to 8 weeks. 7 weeks it will be, right?
It starts from 4 p.m. Right? 4 p.m. weekends.
And the weekends at 4:15 it starts.
4:15 to 2 hours, sir.
2 hours.
Okay.
Okay, fine. If you want to attend Hadoop and PySpark, you need to attend 4 hours continuously, right? 2 hours first Hadoop, next PySpark. You'll be having a break of 15-20 minutes in the middle. Okay, fine. Okay, I'm stopping for now. Yes, if any queries, you can just ping me on that number, right? Yes, related to this. Anyone who wants to attend Python, right? If you want the link for it, means if you have got enrolled for the entire package, right? Okay, fine. Means you have got that online team contact details also. If they are busy with that calls, other things, they're not responding, you can ping me, right? For that. Okay, fine.